All right, welcome to Nested Loops. We're doing chapter 16 of Design Patterns Explained. So I'll just turn it over to Andrew.
All right, I will set up my screen share. One moment, please.
You want to share the name?
Oh yeah, Forrest, what do you think of Hedgile?
What about Hedgile?
Hedgile.
Agile.
Hedgile. I'll think of it.
Okay. All right, guys can see my screen.
I can.
Cool. So this is the analysis matrix. So to start off, this so to start off, we go back to chapter 9, where we had this e-commerce example. So there, our author talks about the strategy pattern. So let's look at chapter 9 and the strategy pattern. The strategy pattern defines a family of algorithms, encapsulates each one, and then makes them interchangeable. Strategy lets the algorithm vary independently from clients that use it. So in chapter 9, what we had was a sales order object, and then we encapsulated the ability to calculate tax, and then from there was able to specify different ways of configuring it using, for instance, like the United States or Canada. But let me keep going. The strategy pattern is based on a few principles. Objects have responsibilities. Different specific implementation of these responsibilities are manifested through the use of polymorphism. And there is a need to manage several implementations of what is conceptually the same algorithm. So in detail, the problem the strategy pattern sets out to solve is that the selection of an algorithm needs to be applied. Depends on the client making the request. In this case, it could be a customer in the United States or in Canada. And if you have several rules that change depending on location, you would use the strategy pattern. But if you don't need the strategy pattern. The solution is separating the selection of algorithm from the implementation of the algorithm. In one section, he says this is like kicking the can down the road, in a sense, where you just keep pushing the problem back. But it's this whole pushing the problem back that allows for this pattern to excel, in the sense that it becomes easier to maintain compared to using switch cases or other ways of trying to deal with it. Participants and collaborators. Strategy specifies how the different algorithms are used. Concrete strategies are the implementations. Context is pretty much the configuration. So let's say the context for a US customer would be a US or United States. For a German customer, it could be Germany. And so the context provides the implementation of the strategy. Consequences. The strategy pattern defines a family of algorithms. You can remove switches or conditionals. And you invoke all the algorithms in the same way. And then he goes on to say that to get the context, there might be an additional method to grab the context for those concrete strategies. Implementation, have a class that uses the algorithm, contain an abstract class that has an abstract method specifying how to call the algorithm. Each derived class implements the algorithm as needed. So I think, and here it is in UML. You can see that the strategy here is abstracted, and you have the different concrete implementation depending on the context. Given some context A, you get concrete strategy A, and so on and so forth for these other concrete strategies. So that's strategy pattern. So let's go into the e-commerce website and get some of our requirements. The requirements at first are easy. Process orders in the United States and Canada. The list is build a sales order system for Canada and United States, calculate freight based on the country we're in. Money will be handled in the currency of the country we're in. In the United States, tax will be calculated by the locale. Use postal rules for verifying addresses in the United States. In Canada, use FedEx for Canada shipping and use government sales tax and provincial sales tax for tax. The first thing that we're going to present is what happens when a customer is in the United States and when the customer is in Canada. So we're going to see the same list of requirements just in a different table. So we can see kind of a way of just getting a handle of the case and then what our different requirements are for each case. So, but a better way of looking at these requirements is called the analysis matrix. And I was trying to get the matrix background. It's like, oh man, this would be cool, but I think that's that. So in the origins of the analysis matrix, the author goes on to say how he dealt with having a project that had so many different use cases and so many different variations that he ended up creating something of a matrix where he would list each use and then the features and how they would change depending on the use. So this was at first just to organize it, but then he kind of just saw that there were a lot of benefits of doing an analysis matrix when trying to solve the problem of commonality and variation in the program. So I see that he put in step one. So step one is to identify the most important features in one case and then organize it in the matrix. So we'll go through. My copy of the PDF had this weird issue where the tables were in bold, or like super bold, or it was so bold that I couldn't read it very well, and I didn't want to present it, so I ended up writing out the tables. So in this table, we start filling in the matrix. So in the left, we see that the common features of our e-commerce product would be calculate freight, verify address, calculate tax, and then the money. And so under the US sales, we would specify these. We would say, if you want to calculate freight, use UPS rates, verify address, use postal rules from the US to calculate tax, use state and local taxes, and for money, use US dollars. And as we keep going, we see that we start filling in the Canadian side. So for calculate freight, use a Canadian shipper. For verify address, use Canadian postal rules. For calculate tax, use GST, government tax, and provincial tax. And for money, use Canadian dollars. Very cool. And then we keep going, and then we add the German sales. Pretty much the same thing, using German shipper, using German postal rules, using the German VAT, using the German Deutschmark. This is old, because now they use the euro. So it dates itself. And talking about dates, we added actually two new features, which are dates and max weight. So we can see that the US now has month, day, year, while Canada and Germany has date, month, year. And then we see that the entries for US and Canada are nil for max weight, meaning that they have no max weight limits, but Germany does. And we see how the analysis matrix, doesn't complain that there's, empty fields there. So one of the benefits of that, kind of just organizing things, knowing that, okay, I have to make an exception for Germany when it comes to max weight. So what do the rows mean? So for each of these 6 rows, we can kind of come up with some way of saying what do they mean. So calculate freight. For all of these, essentially what we can say is that they're the concrete implementation of the way to do this feature. And then for money and dates, it's money is an object that contains currency and amount fields that convert currency automatically. And then the date is an object that contains display so that it displays correctly for the country that they're in. Go on, we see that if we want to ask what do the columns mean, well, the columns are just the implementation that are used when we have a certain customer from a certain country. And so when we implement the strategy pattern, we actually implement it on the rows. And there are certain rows that we can do it. So for instance, calculate freight. This row can now be implemented with a strategy pattern encapsulating the calculate freight rule. So this gets a little bit interesting because the way the strategy pattern works is that you call upon, let's say, calculate freight, and then you can call a method that depends on the context. So for calculate freight, verify address, calculate tax, money, dates, all 6 features are able, you can make strategies out of. Although maximum weight really, I guess it'll return nil for US and Canada. The idea is that when you have the context, you know when you call calculate tax, it'll give you the right algorithm for it using the strategy. I feel like this could be expanded upon, but I can wait until the end. So for the columns, instead of using strategy, we'll use the abstract factory pattern. And I personally have a little bit of some trouble of coming up with factory pattern, but there is a slide that maybe that will help kind of explain the factory pattern. But for now, just all 3 columns for each context gets appropriately applied the abstract factory pattern. So we're going to review a little bit the analysis matrix. In practice, you can use any pattern on the rows and columns, any row and column, I guess, depending on the context. So you can use the bridge, composite, chain of responsibility, command, decorator, iterator, mediator, observer, proxy, template, and visitor. The majority of those I still don't know what they are, but I'll take it that those are very useful patterns. So here's the high-level overview that I was waiting for. So here we have the abstract factory, where you see US, Canada, and German abstract factories. Those were our columns. And you can see how they call out to sales order, given their factory, I believe, ability to call out the right algorithm, where sales order has objects that employ the strategy pattern, or tax strategy, address strategy, and freight strategy. So the way I think I just need a little bit more guidance in abstract factory pattern. It seems that abstract factory pattern provides the context and can grab the right algorithms with that context. I'm not sure. I feel like that might be missing an important point about the abstract factory.
I think it's maybe simpler than you make it out to be. If you just look there, you have a US factory, a Canadian, and a German. And the point is that you have a uniform access. Give me XYZ country. And then in this case, it spits out, the factory here spits out 3 different classes, the tax, freight, and what's the, I can't quite read the address.
Mm-hmm.
Right? And so you use the abstract factory to group together multiple, what is it? We're generating, in this case, strategies, but it doesn't have to be strategies, it can be anything. Whenever you get a factory, if you have more than one set of classes associated with one, you get a factory. A factory, instead of you having to look up each one, get me the U.S. freight, and then give me the U.S. tax, and then give me the U.S. air. You say, no, give me the U.S. factory, and from the factory, I simply call the same thing. Give me tax, get me address, get me freight. So the interface for each country is the same. Get the factory for that country, and then that object responds the same in every place. So abstract factory is basically for family is not quite the right word, but when you have a group of things that are collected together. So
Yeah.
each country does things differently. So we have 3. And maybe you'll add a new thing. Maybe you'll have a credit card processor thing that's specific to each country. Then you'll just add that to this. And then USA factory will have 4 classes instead of 3.
Yes. Cool. Thank you. So with the new understanding of abstract factory and seeing how it just grabs what belongs to it, we can also see how the other factories can grab what belongs to it. We can go on to a sequence diagram pretty quickly, just see how the task controller would go to the factory and say, I want to I guess verify my address. And so then sales order goes to the US address, grabs it, verifies it. And then we can see that sales order is kind of set up so that only the classes that belong, I guess, or are associated with the US factory gets returned and not the other ones. I found this quote to be interesting. Rarely are different cases of requirements stated to analysts or developers in any coordinated fashion. This does not significantly complicate the analysis matrix process. However, sorry, I read that wrong. This does not complicate the analysis matrix process, however. In these situations, I take a feature and look in the leftmost column and see what concept it is a variant of. If I find the concept, I put that feature in the row. Not being able to find such a concept indicates that I must create a new row. So the idea is like gives you some way of going forward with the analysis matrix. If I have a feature and I search my leftmost column for features and I don't see one that it's a variant of or it's the same thing, I have to create a new row and fill out the concrete implementations for my different cases. Kind of nice to just get, in English, what he does with the analysis matrix. Submatrices doesn't go too much into detail, but the idea is that you might run into situations where your implementation requires making a matrix of more features, if that makes sense. So if you're asked to calculate freight for US, you'll have to then decide whether you're going to use US Postal, UPS, or FedEx. And with those, you have different additions to that final sales order. So you might have a pickup charge, and on top of that sales order, you might get the sales order denied if they use US Postal Service and you're trying to ship like an engine block. So let's say no, you probably have to use FedEx. So I guess in not entirely, I think what I would want is some concrete example of this, maybe a database or I don't know. I was thinking of some way of showing this data structure a little bit better, but I think for now it's all right. Yep. So that's about it. That's the analysis matrix. It is a tool to use when you're trying to figure out your features, trying to see how it looks like a very useful tool to implement pattern designs on. It gives you a sense of, are there any edge cases? If there are any edge cases, is there a way that you can kind of start thinking about implementing a way of either solving it or avoiding it in that sense. So we can go on to review questions. So observations. What goes in the far left column of the analysis matrix? So I think it would be good to have the analysis matrix up. We'll look at the full one.
And there's a when I do the reveal JS out of org mode, I have that little navigate thing. I can't see the bottom corner of your thing because the Hangout is plugged. No, there's one that pops up everything in miniature, and I just scroll over and click on it. I don't know if you have that option.
I don't know.
I can't see because it's obscured by the Google Hangouts user thing.
Oh, I got you. I can push it over to the left. Can you see it?
No. The whole bottom row is always obscured regardless.
Can you see it now?
Oh, yeah. No, I had to pull one of my things up, but okay. Anyway, it would have been easier for you to navigate.
Yeah.
If you'd see.
Okay. So here's the analysis matrix we used in this example. So we have the leftmost column. So we see these are our features, and then within it are concrete implementations for each use case. So say the independent feature set. What do the rows of the analysis matrix represent? The concrete implementations of the features. So if we look at it, we can see the UPS rates, candidate shipper trip.
In other words, for feature, it would be a concept.
Concept scope.
Right.
Yeah. And then again, so if you don't have any requirements, you don't have a concrete implementation of the concept. It's just nil or just blank, which is great. Less work to do because you don't have to build something for it. So what do the columns of the analysis matrix represent? Those are our use cases. Those are what we expect to change or what we want to plan for. So the use case defines
implementation.
Yes, the use case defining the implementation of each feature. So finally, which patterns described in this book might be present in an analysis matrix? And then everyone can call out their favorite patterns because it's probably, we can't see it, but there, we would see bridge composite, chain of responsibility, command. There's several others that were mentioned. Template. I don't know if facade would be in there, maybe not. No, probably not. But so we'll go into interpretation. So I'll ask this to Diego. Diego, at what level of perspective does the analysis matrix operate?
What level of perspective? So it works at a conceptual level?
Yeah.
So it's the variation concept.
Now this one's for the whole group. In what way is analysis matrix similar to commonality and variability analysis?
He asks these questions in these ways that I go, well, it's clear to me that the commonality are the rows and the variability is the column. So is that right? Did I say that right? But you know what I'm saying? It's like the concept is, well, they all have address. Well, how do they vary? Well, actually, they don't vary. That's bad. Date. They all have dates, but how do they date? Well, Americans do it one way, and the rest of the world do it another way. And so there's the commonality. We all have dates, but the variability is the different kinds of things. Or for shippers, it might be the German error thing. So it's like in my mind, I go, there are different ways of addressing commonality and variability.
Yeah, I think it does, right? Because the commonality variability is like what are the common concepts and how they vary. And analysis matrix does the same thing. Like which are the concepts that are common? The shipping, cover this, cover that, and then how do they vary in each implementation? Right? I think the analysis matrix is more geared towards the implementation.
Also, it's good I think of it almost like a checkbox or a to-do list. It's like, hey, make sure I have all these cases covered for all my features, or otherwise my product is incomplete. Someone from Tibet will start using it and they'll be like, I ended up overpaying too much. And it's just like, yep, I didn't I didn't take that into account. Because there was a nice one from the UK where tax isn't charged depending on a certain age. So I don't know if that's like below 18 or over 65. I don't know which end of the spectrum on age that is, but that's like another feature. Maybe it's just like the customer age. It's like, are they old enough to get taxed? And this only applies to the UK. Another interesting implementation of this would be the time zones. How different countries implement time zones. In a sense, it's like how we have daylight savings. Other countries don't have that. There might be countries that are defined differently where they have half time zones. So there's like this whole set of features that are very unique. So I think where the analysis matrix might break down is if you have very specific cases that aren't really shared, where the commonality is actually not so common.
Right.
So you have like an uncommonality occurring and you insert it into the analysis matrix, you start ending up with more and more blank cells. I don't know if that's a bad thing, but it's just kind of, you start doing more work for things that aren't really common across. So does it clutter up your code? Does your factory now have to call out something where it's like, how old is this customer? It's like, oh, we don't charge tax. It's like,
No. I'm kind of not seeing what you're saying, but it might be the reverse. You are seeing something that isn't necessarily a complication depending on how you do it.
that sounds about right.
For example, let's go back with the date. So if we look at the one he gave, well, America does month, day, year, and the rest of the world either does it day, month, year, month, day. So you can see in that one, there's two that are the same. So the Canadian factory and the German factory give you the same date, but you've identified the dates are the same. So if we move up to tax, and let's say we go with, I don't know, Vegas tax, well, then you could still pass it a tax, but it's a pattern that's not in the original Gang of Four, null object. You could have a null tax pattern. So you still call it, but you pass an object that just basically doesn't add any tax. And so then this obscure case of no tax doesn't really change any code. So unless you have an example where it didn't meet, where, oh, it's just this guy. Well, if it's a common thing, then you address it. If it's not common, then it doesn't show up in the, it doesn't show up as a row.
It gets handled
because whatever handles it in that specific thing.
That makes sense. All right. Yeah, that's pretty much where I was thinking. So yeah, cool. Let's go to final sets of questions. Opinions. Can patterns help handle variation more efficiently? Yes. Efficiently in the sense that when you, for this case, the strategy pattern, when you employ a strategy pattern, you can handle variability more easily than trying to have a set of switch cases, where you have a new pattern, you have to implement more and more switches. When you have a new feature, you implement more and more switches because you're trying to say, well, I have 150 countries that I'm taking care of, and I want to make sure that all of these new countries are now aware of like this new carbon tax that's added to it. And some countries have it, some countries don't. So just got to make sure that's properly taken care of. Whereas you can just,
if you have a new feature, actually it's a little 601 versus right? Because like if you have a new feature, let's say you use switch cases. You add one method to the current class with 60 switch cases. And with this pattern, you add a method to 60 classes.
Yeah.
The same method to 60 classes.
Yeah.
So
yeah, you got to think.
But it's a little bit. I still think it's easier to reason about it.
Yeah.
Right. Because like the temptation with the switch cases, it was like, oh, if it's any of these three, or if it's any or else, like, so you have to look for like imagine like Italy.
Yeah.
And you need to look, you don't find it in any other cases, then oh, must be the else case, right? Rather like with the Italy class, you can easily see what's going on.
That's true.
I think clarity.
Clarity, yeah, that makes more sense.
The major thing. I think variation. I don't know if it's more efficient, but it's definitely less more clarity.
Well, I guess clarity and readability makes it more efficient if you revisit the code. So, do you agree with the observations about users made in this chapter? Can you give examples from your own experience? Oh, so he's asking, is this common from the people you've worked with who provide the right requirements, where they start, they might have some vague notion of what they expect, or when they say always, like, or never, in a sense. But then you find out that they missed like important edge cases, and it was your job to kind of like know that. I guess that's he's asking, is this something that's common? Is this a commonality between us as developers? And what is the variation that each of us experience?
I think no one ever knows what they want completely. And they certainly don't think about all the edge cases. So I don't think you could expect the customer to come to you the way you want it, unless that customer was already a developer. And even then, If you don't go to the rigor, just let it happen.
Do you believe that the analysis matrix is generally useful for most problem domains?
Yes.
I guess the question would be, what are some problem domains that analysis matrix wouldn't be useful for?
It wouldn't be useful?
Right.
Or you can prove a negative?
No, just to get an idea of like, if it's yes for most of them, what would be the no for like the one or two? Then?
I think for cases where it's too simple, right? So overkill.
Yeah.
Or cases that don't have commonalities.
Well, that helps too, because then you know that you don't want to put that feature within that set.
Okay.
Like, hey, this only has one item and the rest are nils or nulls in this row. That could be like an analysis matrix null. This is a lack of entries.
I do it all the time, but I never call the analysis matrix.
Yeah.
Yeah. Go ahead.
Oh, I was going to say, you keep it in your head, right?
No, sometimes I write it on paper.
I think when I look at the tools, and again, the whole commonality variability, in my mind, that's just 00101. Once you have this class, once you have a class, subclasses, you kind of already looking at, oh, here's an animal class, and of that I have, you know, dogs versus cats or whatever, maybe, you know, animal, mammal, however. So you kind of always do that. The question is how formally do you spec it out? Right,
and also sometimes classes can be pretty big, right? So it's hard to see the commonalities. Like this one, I generally, like a lot of time when I refactor, what I do is I format the code as closely similar as possible in different classes, and so I can compare apple to apple, right? And I can easily see what's changing. And then if it's complicated, if I have like a 2 or 3, like more than 2 classes generally, on a piece of paper, I'll write down, or on TextMate sometimes, I'll write down like a matrix. But I'm not structured to say on the left I put the method. You know, like sometimes I do the opposite. I do on the top I put the method, on the left I might put like
you do the
class.
The transpose.
Yeah.
Of the analysis.
I do Excel transpose.
Yes.
I kind of I think when I'm thinking things out, I sometimes write bullets. Like I sometimes design with org mode. Sometimes I start to pseudocode, which very quickly becomes Ruby anyways. So I just write little, I mean, because Ruby is basically pseudocode that runs a lot of times. And so I do find myself like writing some notes and then org moding it and then just starting to write basically classes with no actual functionality, but titles, you know.
Well, I was talking just earlier with Andrew about this book called Agile Modeling. And the question how you guys promotes, I think it's Amblin, that I'm going to talk about. It talks about like using like a very lightweight tool, like either pen and paper or sticky notes to draw boxes and do or dry erase board. So like what we can do is like on a dry erase board, you'll put sticky, like, and each one will be like a class or an object or concept. The way you can actually move them around, and you can try different design pattern and see what works best, right? Which is, I think this is something I might, when we have our shoot the poop meeting, I might talk a little more, because I'm trying to formulate an idea and process or an exercise around this. like to one, learn UML a little better, and two, do like a rapid firing design pattern.
Yeah.
Like, so they become second nature.
UML is good for that. I sometimes draw some class diagrams when I'm fleshing those out. CRC cards is sort of kind of describe what you kind of described a bit. CRC card, class responsibility collaboration.
Right.
CRC cards is basically kind of pseudo UML-esque thing, but done with note cards. And the beauty of that is you can organize them however you want. A lot of times more easily than with a UML drawing tool, or I can just like grab 3 cards and lay them on top of each other, or stack them, or fold them where you can see the titles and nothing else. So the old-fashioned, and I know there's some like CRC software there, but sometimes just the old cards, just yeah, like that. You see that picture that I guess Andrew's showing right now. Writing these cards, having a big table, spreading. Or you could stick, you could stick them on the wall, however you want. But you can sort of see as you start writing, and this is kind of the thing where I go, sometimes you don't know the commonality, you start fleshing them out. I go, I got this, and I got this. I go, oh, wait a minute, these 3 things share 3 of the same responsibilities. Maybe they're subclass, or maybe they hold something that's in common of all of them. And so a lot of times I think you don't see, it's like, when you write the book, you already know in the chapter what the commonality is. Like, hey, the commonality is this. That's why I found funny when he said thinking in patterns. Well, see what pattern is here. You don't know sometimes until you flesh out the details. You don't know what's common sometimes until you start to really get close to coding where, oh, I got to do this, this, and this. Oh, that one does this, this, and that. That's 2 out of 3 the same that you didn't know until you got down to that level. So just kind of writing responsibilities here. And you can sort of say, so the class is the top, the left is the responsibilities, and the right is who it collaborates with. And arguably, someone could write a really good, I think, tool. Maybe that'd be an exercise for us to do a little React CRC app that's remote, real time. So Scott could drag a card on top of another card or something. That might be a fun project to do. I haven't looked at CRC software in a while, but none of them were really good. Get off your cord here. Which cord? Thanks. So, yep.
So in this case, would I take the order card and like place it here on top of this order section?
Well, the key is you can do whatever you want. Let's say you wrote 6 of these cards, and then 6 of them have order. Then you might lump those 6 together to be closer to order. Right? Mostly it's just it's a simple format that lets you put some stuff out, and how you order the cards depends on what you're trying to do. A lot of it is just when we talk about like working things out, it's just like it's a scratch pad. Do whatever you need, and because it's physical cards, you can do stuff that's really hard sometimes in software. Like I can tile a bunch, or move this, or just put a stack. Sometimes I don't want to see all the cards. I realize there's 6 things that have order, and I make it a stack to make more room for other things. So it's whatever you want to do. And I know, as someone who's asked me the question, that's the worst answer you want to hear. Whatever you want. No, tell me what to do. No, it depends on what you need. And then, well, give me a specific. It all comes down to here. Give me a specific.
Like we'll use CRC cards to make our CRC JavaScript program.
That would be fun. That would be surprisingly meta. Recursion. We go into an infinite loop and never finish coding.
It's CRC cards all the way down.
There you go. So good. That's great.
Yeah, but a lot of time, Ron Jeffries joked about it. Hey, the index card is your $1 case tool.
I think we're missing. We should get index cards. We should ask whoever we ask for sales. Office
yes, Tanya, or actually Phyllis now, I guess.
Yeah, Phyllis. Yeah. I'll ask Phyllis.
All right, who's doing the next one?
All right, the next one is the decorator. I'm gonna see how many pages it is here. One, two. Decorate's an easy pattern. I can't imagine it's very long. Yeah, it's not too long. The one after that, value of other patterns, observer, 1, 2.
10 pages.
Observe next. Decorator and observer are short. We could probably do 2.
Yeah, both 10 pages.
I think.
2 people can like do a double team.
Yeah, you could. I mean, we could. I would probably just. That would be. I don't think we've had a session where 2 people spoke. Is that true?
Oh, in that case, I say perfect. Don and Alex.
Okay, if Don's cool with that. Which one does Don want, since he's actually here?
Oh, that's easy. He's the observer because he's here observing.
Oh.
No, I'm just kidding. I'll do observer.
Okay, we'll let Alex know. He's got the decorator, which is among the simpler patterns and handy and easily demonstratable in Java code because they use that all the effing time. In fact, I/O is a confusing morass of classes that hold other classes because of the decorator pattern.
All right.
Okay.
All right. Well, thank you for coming to N3ST3DLOOPS. Thank you, Andrew, for making your cool org-driven Reveal.js. I'll show you after we shut up. I'll show you. Yeah, I'll find one of my things and I'll show you. So I'll stop the broadcast and show you that.
Okay.
Great. So there you go. Thank you, and see you in 2 weeks.